Hi everyone, just having a go at wiring one of these plug and play grid tie inverters in. They just plug into the wall. They're pretty common now. There's a little bit of controversy about them, whether they are pure sine wave or not. That's modified sine wave, and they're saying that that's a pure sine wave. If you're not sure about the difference, I suppose it's probably just as easy to draw it out. Modified sine wave, basically, if you remember back in your physics lab, you had to run your power through your oscilloscope. You'll get that pattern. That's modified sine wave, and basically that's what they call square wave. And then you've got pure sine wave, which would run through the meter, be very smooth, and that's pure sine wave. Now, modified sine wave, cool for things like incandescent lighting, any elements. When it comes to fluorescent lighting, you've got transformers, you've got capacitors in there, so you're going to need a pure sine wave. Now, when it comes to grid tie inverters, which are actually powering your power back into the mains, whether they're true pure sine wave or not is debatable. But anyway, it's all we've got, so we're just going to run with it and give it a bit of a road test. We've plugged it into our wind turbine, and this is a three-phase wild AC input, and it comes in here, goes through a rectifier and comes out DC here, and then into our inverter, grid tie inverter. Now, I was testing out these two power analyzers. This is a dot watts up meter, and this is the Turnigy. Basically, they're pretty much similar. The only difference is the dot Watson has a kilowatt hour data reader, and the Turnigy has a watt hour data reader. I do prefer the blue. This has got a blue LCD display, so it's a lot easier to see. So I prefer this one to that one, but if it's all you got, it doesn't really matter. They're both the same. And so with the this has an operating voltage of 14 to 28 volts, and obviously with your wild AC converting to DC, you're gonna cross that boundary, and you're going to get up to like 38 volts I was getting from my wind turbine. As the voltage increases, your ampage drops. So basically I'm considering whether it's wise move to use the battery as a more like a capacitor to hold the wind turbine into the correct operating voltages. But we'll see what happens in the next video, and when I try that. Or if you've done it before, anybody out there that's done that and wired it into a battery bank, not for the purpose of powering your house, but literally just to hold the voltage, what will happen? So that'll be quite interesting thing to do next. But apart from that, it worked okay the other day. We were decreasing our utility bill. It was dropping the power, not by a great deal, but it was working. And in the future, if we'll be investing in obviously a lot bigger one, whether we'll go for the Chinese model, I don't know. There's a lot of good European ones on the market, but the price. I suppose you get what you pay for, basically. And so anyway, drop us a comment if you reckon you can hold the voltage by running it through a battery bank, and if I did do that, what are the consequences? Anyway, thanks for watching. Being from the west coast of Ireland. Bye.